Let z be x times e to the xy, x equal t squared, y equal t to the negative first power. We want to find the derivative of z with respect to t. First note that z depends on x and y, and both x and y depend on t. So if I'm trying to find the derivative of z with respect to t, I have to go two different paths from z to t. First, I'm going to go from z to x. Because I'm given two choices, or two paths from z to t, z will have to go, we have to use partial of z with respect to x, and then from x to t you only have one path. So that's dx dt. Now we go to the other path. Z again has two options here, so we're going to say partial z over partial y, and then y only has one choice or one path, so that's dy over dt. Now we just take the derivative. Partial of z with respect to x, well, this you have to use the product rule. So take the derivative of x is 1 times e to the xy plus the derivative of e to the xy with respect to x is y, then multiplied by x. So this would be xy e to the xy times dx dt, that's going to be 2t, plus, now we want the derivative of z with respect to y. So x is going to be a constant, so that's going to be x squared e to the xy, and the derivative of y with respect to t, that's negative 1 over t squared. Next step, we can replace x and y with respect to t. So x is t squared, y is t to the negative first. Then multiply that by 2t. X we said is t squared, so that's x squared will be just t to the fourth. And then we have e to the xy, x is t squared, y is t to the negative 1. And multiply that by negative 1 over t squared. So t squared times t to the negative 1 is just t. So it's e to the t plus t squared times t to the negative 1 is t, e to the t. This whole thing times 2t plus, now we have t to the fourth times negative 1 over t squared. That's negative t squared, e to the t. I'm going to simplify this so I can distribute out the 2t. That's 2t times e to the t plus 2t squared e to the t minus t squared e to the t. Finally, we have 2t e to the t plus t squared e to the t. And this is our final answer. We're given x squared sine of 2y minus 5z is equal to 1 plus y cosine 6zx. Let's find partial of z with respect to x. Well, the formula we're going to be using is, this is negative partial of f with respect to x, partial of f with respect to z. So this is going to be the shortcut formula. And the key to this is to make this equal to 0. So I'm going to subtract 1 plus y cosine 6zx to the other side. So take this with respect to x, that's 2x times sine 2y minus 5z. Negative 1 is a constant, that's 0. And then minus, this is going to be, well, first you got to take the derivative cosine, negative cosine, which is sine. So it'll be y sine 6zx. And the derivative of 6zx is just 6z. So we'll just stick that in front. Now the partial with respect to z, I have x squared here. Derivative of sine is cosine. And then the derivative of the inside, 2y is 0, negative 5z is negative 5. Negative 1 derivative negative 1 is 0. And then here we'll have, again, derivative negative cosine is sine, so this will be plus y sine 6zx, and then take the derivative of 6zx to get 6x. And this is our final answer.